you ever looked at sand through the microscope? Okay, so I'm gonna show you some really, really cool sand. Okay, so basically what a microscope does, it makes small things look bigger. Exactly. So, and what I've got here is something that you might not have ever thought of looking at through the microscope, and this is sand. And I've got some very special sand here, and this is Durban beach sand. Okay, so, and you might think, oh no, Durban beach sand is not really special. Various ways. So I don't know if you've ever been to the Durban beach?
Yes.
Yes. Okay, so have you ever noticed these black strips alongside the beach? The black spots? So what do you think what they are? Okay, so people often think it's oil, and you know, the sand looks really dirty, it's oil or some other dirt. And now the microscope is going to reveal what it actually is. What you will notice is the sand, but also you see black grains. Do you see them?
Yeah.
What I've got here, this is the heavy mineral sand, this is just ordinary sand, and I just want to feel you. Do you notice a difference?
Yeah, this is heavier.
This is heavier than this one here. Does everybody know what this is?
Magnet.
It's a magnet. Okay, so, and now what I'm going to do is, I can actually extract some magnetic minerals out of the Durban beach sand. You want to try it out? So what is special about this sand is that it's mined up in Richards Bay. So the magnetic mineral contains iron, but there's also minerals that contain, for example, titanium in it. So your ilmenite, and here we have some rutile with some garnet in here. So they contain titanium, and this is what they're mining up for in Richards Bay, for its titanium, so that you can convert into titanium dioxide that makes your paint white, your paper white, and so on. And also we have zircon, and this is a special material, for example, for your screen. Some people use it to make very scratch-resistant screens. Okay, so if you want to follow me to have a look at some cool rocks. So you know, remember you have your three main rock types. You have your sedimentary rocks, they are over there. We have our igneous rocks. So these ones are basically rocks that come from, you know, volcanoes. So you have your extrusive rocks. And then we have our metamorphic rocks, which are basically reworked, either metamorphic rocks or reworked sedimentary rocks or reworked igneous rocks. Okay, so I've got some very special rocks here, and this is for really, this is for really, really strong men and women. Okay, so you need both hands, and it's super duper.
Looks so small, but it's heavy.
It is heavy. You just want to pass it around?
Yeah, but it's a pretty rock.
It's really pretty, it's like the lights.
Okay, and what is special about this rock? Yeah, this is especially bad when you have a compass and then you try to take the reading, because your compass goes all over the place. Okay, so that is a banded iron formation or banded ironstone, where you have layers of metal in between that are basically magnetic. And then this is actually from close by here in KwaZulu-Natal, from the White Mfolozi River. So where you find lots and lots of you know, interesting, or lots and lots of these banded ironstones. And banded ironstone is also very important because they are the first indicator of oxygen in the atmosphere. And these rocks often date back, I think, I'm not too sure I think they're around 2,800, 3,000 million years old, these rocks. So very old. Okay, so, and now, this is seriously for the strong man.
It's lights.
Are you sure?
Yeah, it is.
Just pass it on.
Oh yeah, very light.
Like a sponge.
Yeah.
Is it found at the sea?
No, this is in fact a volcanic rock. This is a frost version of this rock here. So this is an obsidian. So that's volcanic glass. Okay. So you can see it's quite shiny, and just like glass, you can use it actually as a cutting tool. So imagine a Coke bottle. You have some liquid in it. okay? Or some Coke or whatever. So just imagine that this is your magma. So now when you start shaking it up and you open it, what do you see?
It fizzes out.
It fizzes out, so foam is coming out. So this is actually exactly what this is. It's foam. It's foamed obsidian or foamed glass. And also, ladies, what you might notice is you can use it to scrub your heels, because this is pumice. This rock here, okay? So this rock here, and it looks ugly, hey? Let's put it like this. But it is actually a quite interesting rock. Can you see these lines here? Yeah. So what you're basically looking at are mud cracks. Do you know what mud cracks are? So when you have very fine-grained sand and you have water coming in and it dries up, then you see your patches crack up. So that's what they call mud cracks. And so what is quite interesting is, what do you think how old this rock is? I know this is a stupid question, but because you probably won't know. But I love people to guess, you know. So I can prompt myself to be very clever because I know the age.
Age of the dinosaurs.
Okay, so age of the dinosaurs. So that's round about, you know, depending on what kind of dinosaurs we're looking at, up to 250 million years. Okay.
I think quite recently, maybe 10 years.
10 years. Okay.
The Stone Ages, I don't know.
Stone Ages, so that's like, oh God, now I have to go back like 10,000 of years, okay. All right, if I'm going to tell you that this particular rock is about 2,700 million years old, so 2.7 billion years old.
Older than dinosaurs.
Older than dinosaurs, so they've already seen it, they've seen everything, dinosaurs, humans. And what is quite interesting is that geologists also use rocks to learn something more about it. So what we know is, we know now what kind of condition this rock was formed 2,700 million years ago. It must have been had some form of water. Okay, so here we go. Even though we weren't there, we can look at rocks and then figure out what basically happened. This is a typical kimberlite. And kimberlites come in all sorts of different weird forms, looks, and so on. And this is how you would find diamonds. And these ones are basically rocks from a diamond mine high up in Lesotho called the Letseng Diamond Mine. And they produce very, very large and nice diamonds. So I was very lucky at one point to hold a diamond about that size in my hand, a raw diamond. I mean, this is like seriously nice. It was seriously nice. Seriously nice. Okay, but you know, these kinds of rocks are also interesting for other things. Not only bring they up diamonds, but they also bring up rocks from very, very deep down. We know now how mantle rocks look like because things like kimberlites bring them up from deep down. So this is a very typical rock. So this is a granite, okay? And you can see this, some of these shiny black things here. This is in fact mica. This is a volcanic rock. This is a basalt. And this is also a volcanic rock. This is a rhyolite. And can you guess where they're from? They are in fact, and you might have seen them they're actually here from South Africa, from KwaZulu-Natal. So this one here you find on the top of the Drakensberg mountain. And this one here you find when you go up to Jezini, Lebombo Mountains. And coming to our metamorphic rocks. And sorry to say, I'm biased because I love metamorphic rocks because they are so pretty. This is the non-scientific name that some of our former students said. How it's called? It's called glitterite because it's so glittery.